Schedule optimization, matching equipment operational schedule with load requirements. As shown on this slide, there are several ways to optimize energy as part of a Facility RCx event. Scheduling of equipment, whether it is achieved through trimming operational hours or start-stop optimization, is perhaps one of the most common and attractive category of RCx measures. The reason why scheduling is an attractive RCx measure is due to the fact that scheduling opportunities are relatively easy to identify and usually have potential for upstream savings as well. Scheduling measures are also relatively easy to implement. Today we will focus on the Scheduling RCx measure, and by the end of this video you will notice that the concept can be applied to a variety of HVAC and lighting systems. As an example, let's look at scheduling of air handling units. This graphic shows an AHU with chilled water coil which is served by a chiller, and the chiller has a cooling tower associated with it. So essentially, any reduction in the operational hours of the AHU may translate to additional savings at the chiller, tower, and pumps. If there is a boiler providing reheat to the VAV boxes, not shown in the graphic, then there may be additional savings at the boiler and the hot water pump. To optimize the scheduling of the air handling units, you can start by asking several questions such as, what is the current operational schedule? Is the schedule adjusted seasonally? What are the zone requirements during unoccupied periods? And is there an opportunity to further optimize the schedule if one currently exists? These questions will help determine whether or not the Scheduling RCx measure should be investigated and what data and analysis should follow if the measure does qualify. If it is decided that the Scheduling RCx measure is to be investigated, then operational data will need to be collected and analyzed. The data that needs to be collected is the AHU operational hours and its electric consumption. This data can generally be obtained via the building automation system or data loggers. In some instances, certain locations or zones within the building need to be maintained within certain temperature and/or humidity parameters. In those instances, zone-level data will need to be analyzed. Where upstream equipment such as hot or chilled water systems are expected to save energy as a result of implementing schedule changes, consider including these pieces of equipment in the analysis. To implement the findings resulting from the data analysis, it might help in some cases to communicate the findings to the building occupants. It's also helpful to implement the changes in gradual time increments and track comfort calls as the changes are made. Then, adjust schedule changes accordingly. Scheduling changes will typically be implemented through a front-end automation system by directly programming digital controllers or with a simple electronic time clock. As we will see shortly, trend data of existing startup zone and outside air temperatures can be used to better estimate warm-up or cool-down times needed. We will now review a brief case study where the Scheduling RCx measure was investigated. To determine the schedule of the AHUs, energy trend data at the Motor Control Center was obtained. The MCC at the site happened to have all the AHUs on it, so it was easy to collect data at the MCC level. The data shown on this graph is for the month of May, where the hours are on the x-axis and the demand is on the y-axis. As can be seen, the AHUs are on a schedule, turning on at 4:30 a.m. and turning off at 7 p.m. The facility staff was aware of the early equipment start time, but weren't sure if the time was optimal. The normal time during which staff arrived at the building was around 7:30 a.m. To estimate optimal AHU start time, several zones that were termed as important were identified to be monitored. These zones included a mix of internal zones that were in constant need of cooling, such as the copier room as well as offices of senior executives. As you can see from the graph, there were some zones that stayed warm during times when the AHUs were off. When the AHUs turn on at 4:30 a.m., the zones reach their operating temperatures in about 45 minutes. So for this facility, the catch-up time was approximately 45 minutes. However, people don't start arriving until more than 2 hours later, around 7:30 a.m. The AHUs are essentially running for 2 extra hours a day. The building staff used this information and reduced the operating hours of the AHUs, and since the electric data for the AHUs was readily available at the MCC, it was relatively easy to calculate energy savings associated with this measure.